Or squared.
You guys remember this formula? 4/3 pi r cubed?
Yeah.
Cool. Anyway, it says the volume is 4.19 cubic meters. Where does that go? Okay, so this should have been pretty fast to solve. But what should you do first?
You can divide by.
I wouldn't cube root yet. How about multiplying by 3 over 4 pi?
Wait, why would you multiply?
Well, because then we can, it's easier to see the 4 and the 3 cancel on the left, on the right.
Well, yeah, but it's multiplying.
Which is better.
If you divide by it.
Exponents comes before multiplication.
Okay, so 4.19 times 3 over 4. Probably should put that in parentheses. 4 pi. Shall we get 1? How about that? Works out just right so that the math is equal. So what is r?
1.
It's 1. How did you get that?
I keep rooting.
Yeah, cube root. Remember, you can cube root. So you can do that, or you can do r to the third to the 1/3. How many of you are preferring the cube root method?
Huh?
I have no.
Oh, no. I love you.
Okay.
I'm bad with names.
All right. How about this one? I haven't done these in just a little while. Definitely need to be able to for your final. So I hope you're starting to prepare for that.
Not at all.
Well, this is, but not everything on there will be. How do you solve this one?
Or I
Why are we adding 12? Why do we want it set equal to 0?
So we can either use a quadratic formula or see if we can
Find the x-intercepts.
There you go. We want to find the x-intercepts.
that too.
What's the next step?
Greatest common
Is there one? What is it? Okay. What is the purpose of the GCF? Of taking it out right now?
To make the numbers.
Make the numbers smaller.
No?
Oh, okay. Well,
But they're not so big.
what's the correct answer?
I'm waiting for you to tell me.
Well, what do you think? I'm curious to know.
We're curious on your opinion.
You want my opinion?
Yep.
How convenient.
How convenient.
Alright, well. Look, I guess it's probably worth looking at. Let's do the star without doing the GCF. So we're just going to take 10 times 12. So 120, and we're looking for factors that add up to 126.
To 126? That is
Negative 26.
Negative 20.
Are there some?
Yes. Negative 20.
At some point, yes.
Okay.
Yeah, see, ugly big numbers.
Beautiful big numbers.
Now what?
Don't hurt her.
Now what?
Simplify the fractions.
That's
Okay.
negative 1/2.
I'm going to write it as 1 over negative 2. How about over here?
Over.
5 over negative 3.
Negative 5/3.
Good job.
Okay. Here's, well, I'm not going to say it actually. I want you to tell me.
Okay. Uh-huh. What the actual word?
Wait,
We
what?
want to
Nobody seeing it?
Yeah,
The negative 2.
the numerator becomes
make
the
the
amount.
3
of
halves,
x
the
is,
3
and
fifths.
then
Oh,
the
it's
denominator
because.
becomes-
Okay, hold on. Let's do this one.
Oh, yo, you didn't put out the 2. No, because we just did the one without the 2.
Okay, how about over here, factors that add up to 13?
Negative percentage motivation.
15 and
15.
Oh, what?
Is
Okay,
that what you said?
What?
That's what I said.
that's not
I mean,
right. Okay.
no.
Okay. So here's what I'm saying. Look, our factors become the same exact thing, which tells you what?
It doesn't matter.
It tells you that your zeros are the same. However, with this one, you saw that you pulled out a 2 and you know that that's a factor. Over there, you completely miss it. And so it doesn't change, pulling out the GCF doesn't change finding the zeros or the roots at all. Do you see that? They're exactly the same. But pulling that factor out, you won't miss that it's part of the factoring, whereas over there probably you would. And so if it said write in factored form, so do you guys remember, the functions that had multiplicity and end behavior and all that kind of stuff, right? So you did your synthetic division, a bunch of division, bunch of times, and then when you got to the point where it was, well, I'm just going to make up numbers, something like this, what did those represent?
X-intercept.
No.
No.
That was the quadratic formula where you could factor, right?
When it got down to this, with 4 numbers, one of them being the 0 at the
Oh,
end,
you can start.
we can rewrite this as 3x squared plus 2x plus 1. Remember that?
That's right.
Okay? And I probably should have made this negative, but there we go. Okay? So what I'm connecting this to is you didn't want to continue doing long or synthetic division because you might have another 10 factors to check or potential ones. So we always started with the star, right? Once you got it down to 4 numbers with the last one being 0, then you went to the star. Well, if this one doesn't have a GCF, but if you did it like this and you listed these as your factors, you would be missing the 2 that we pulled out. Therefore, your factoring would be wrong.
But.
Okay? We did pull out the 2 here, we just didn't show it. We pulled it out of both sides. We just didn't show it. And that's why I'm saying it's easy to miss. And you're not even thinking, typically when you're doing the star, you're not even thinking factoring, you're thinking finding the zeros, right? So that makes it more obvious, that doesn't.
For this side, wouldn't negative 15 and 2 also work? And then that would change the answer?
No, because it would have to be negative 30.
Okay.
Yeah. So there are more of those kind of cases than you would think, where there's more than one set of numbers that would make the denominator number, or the bottom, I mean, the b value, but the sign doesn't work. So what, you guys summarize. Why do we pull out the GCF? Yeah. You will miss the factor, right?
So you have no faith in us.
Well, it's not that. We've never talked about when we divide here, talked about that as the GCF. Because I've never said do it that way, because I want you pulling the GCF out first.
Yeah, I'm just playing.
Okay, so be careful. Again, it does not change the zeros at all. It just changes when I ask you to factor something. And that is important, right? We want to know the factors sometimes. Anyway, what are the zeros? I think you might have said this already, but what are the zeros?
2
Good. How'd that one go? Did I answer your question?
Would we also use what you said for graphing?
What do you mean?
So, since we have like the 2 on the outside, and we have another factor 2 on the inside, would that be a good example of wanting to use like the taking that out first type of for graphing?
Well,
since we have 2 times.
Are you talking about this 2?
Yeah.
Okay.
Since it comes 2 times, he wants to use that in when you grab. That's what
I think so this is a parabola. So you want this out here so you know what A is. But this 2 doesn't matter. Like that doesn't play a role.
it doesn't bounce or anything.
Oh, I see what you're saying.
Yeah.
Okay. Now I get what you're saying. Look here, everybody. Let's do a brief review. This will be on your test. I'm going to give you a function and say, just like you had back probably February or so. Here's a 5th degree polynomial. Give me all the zeros, write in factored form, and graph it. Okay, do you remember that?
Yeah.
Basically, it's a blank page with room to work and then some graph paper or a graph grid. Yeah. So how do we know when it bounces?
When it's even.
Even what?
Even. Positive.
Well, the positive didn't matter.
Even exponent.
I'm saying what is even though.
Oh,
Okay, good thing. This is good to review, so make sure you're with me. Okay, remember a factor. Probably should make that negative since it's bouncing. On the right. If a factor had a negative, or excuse me, an even multiplicity, right? It shows up more than once in an even number of times. Okay, so 2, if it said 4, it would bounce, etc. Okay? So make up a factor that could be.
Great.
X plus 1.
Well, that would be over here if I made this one be a 4.
X plus 5.
X plus 8.
X pluses would be over here.
X minus 8.
X minus 8.
Okay, we'll go with x minus 8. What about the exponent?
3.
Okay,
That's
it's not a 3 because it just passes straight through.
So 1.
So it has to be a 1, right? Let's change this.
Oh, that's cute. Okay.
We'll make it super obvious.
So that's like X plus 8. Or is 30.
Okay, what would that factor be?
X plus 8.
Okay, sure. So remember, odd multiplicities greater than 1 would kind of curve through. Okay? So what would the degree of that polynomial be? Actually, we missed one. What would that one be? Like make up a factor.
Oh, sorry.
X
X plus 1. I thought you were still on the
Okay.
degree part.
So don't shout this out, but what's the degree of that polynomial? Okay, what are you holding there? What's the degree of the polynomial?
Like, we're all waiting for you. Me? What's the degree of
Have you told me yet?
Oh.
Okay, should be 9, right?
I
So this is
totally messed
x
that
to the
up.
4th, x.
I was like, what?
So we're at 5th, 8th, 9th. So remember end behavior? How do we know that it looks like that for end behavior?
Because it's 9.
Because it's
Because it's
Odd.
Odd,
Even.
Hey.
even.
Sorry.
What is
1.
this?
Oh.
Negative even.
Negative even.
Negative odd.
That's okay.
Do you remember synthetic division?
Yeah, because we did the hand. It's like, walk the line and you
Did you really do that? You really did that?
She'll buy that.
Oh.
How do we do synthetic division?
we first drop down the first one.
Oh.
Bring
Yeah,
it down.
and then you times it by 4 and put it, so then it's 20, so then it's
Okay, then here do we subtract or add?
Add.
Yeah, so probably a good idea to write add because it's different than long division. It's subtraction. Okay? Now what is that? 80 plus 24, 104. Okay.
I liked
Is it gonna work?
No.
When I say work, what do I mean?
is 10
Is it
to
good?
0.
Yeah, good.
am I gonna get a 0? Yeah.
No.
When I say work, what else does it mean? When it is a 0, what does that mean?
It's a factor.
It's a factor. Okay, that's what I'm asking. So yes, you're looking for the end of your synthetic to be 0. If it's 0, it means it's a factor. Let's say it was 0. What is the factor for this?
I remember getting both.
X.
Waiting. What's the factor?
X plus 4.
No,
Negative.
that's the 0.
X minus 4.
Okay. What was your question?
How did we find like the factors from just having numbers?
Okay. Let me fix this, or not fix it.
Wait, where did the 10 come from?
I'm just gonna rewatch all of them.
It was just a number.
Where did that 10 come from?
Yeah.
I just made it up.
But like,
Yeah. Yeah. Don't you do that right on the side?
No.
Yeah.
If the 4 was negative, could it might have worked?
Now, why don't you try it?
No, walk with the Egyptians.
I don't know, it wasn't. And negative 1.
Okay. First thing, if you're going to long divide this, actually both, synthetic or long divide, what would you have to do?
Start out by crying and then look over notes.
Look over that function that I just wrote.
Oh gosh.
If you were going to synthetic or long divide it by something, what would you have to remember to put in?
Didn't we have to like create this long list?
That's what Nate's asking about. We're going to do that in a second. But before that, I'm asking, what would you have to do with this to start the division? So think about setting it up. What am I writing? 3, 7, negative 3.
5.
You skipped something.
I did.
Yeah.
Oh, because.
Oh, fish pot.
Pish posh, huh? Don't forget it though, because if you did, it would really throw you off. Because how many zeros could this, how many real zeros could this have?
5.
Okay, how many total zeros does it for sure have?
Definitely 1.
5.
5.
Has to have, right? Some of them might be non-real, but it will have 5 zeros of some sort. Okay? That was the fundamental theorem of algebra. So if you missed that 0, would you be starting with the 5th degree polynomial?
No.
No. So you would only probably at most get 4. You would miss 1, potentially. So, yeah, don't forget. I'm just going to leave that as a reminder. And then to Nate's question, we had what we always called possible roots. Do you remember how to do that?
No. It's
Okay.
5th degree. You
Positive and
factors
negative, what?
apply to.
What?
It's for the highest degree one and the one that doesn't have X on it or whatever.
Okay, factors of the constant
It seems that multiply to make that number.
over factors of the lead coefficients. Which is what in this case? 3 is the lead coefficient, 24 is the constant. So just write plus or minus. You don't have to write all the positives and all the negatives. Okay, so let's start with factors of 24. Go.
1, 2, 4, 6, 8, 12.
You forgot 3, so I added it in there. Okay, and then over factors of 3, 1 and 3. Okay, how do we generate our list from there?
You do it.
All these have to go over 1, and then all those over 3. And then there's always repeats. So we'll get positive and negative
1,
1, 2,
3,
3,
okay?
4.
3, 4.
All of those will happen, for sure, okay?
And then.
Okay,
1
but now we're
third,
gonna go over the 3, so 1/3,
2 thirds,
2/3,
4 thirds,
4/3,
6 thirds.
6
no,
thirds is
That's
2,
2.
8 thirds, and that's all, okay? So how many possible roots do we have in actuality?
12.
24.
Oh, that was
Oh,
it.
yeah, this one.
Oh, yeah, that's right.
How would you start checking if I asked you to do possible roots?
Small start with small.
Okay.
Small hole.
Yeah, start at 1, maybe do like 1, 2, 3, and then maybe a negative. Might have to do fractions, okay?
9 out of 10 times, not the biggest number.
Maybe even 10 out of 10.
Wait, what?
There was that one time, so that makes it 9 out
There
of
was
10.
not a one time.
Yeah,
Well,
there
not what
was.
we did. I'm not saying it can't happen, but he was pointing out that it's rarely the bigger number, right?
There was one time
'Kay.
where it was.
That was a quick review of all that. Remember doing this?
Honestly.
It seems like it kind of came back to you. Okay. Then think through the process. You would start your synthetic division, do a whole bunch of those. And as let's say you try one and it works. What are you going to do with that?
Reset it
So
up.
we try 1. Remember, first of all, to put 1 here, not -1. Okay, and then you get all these numbers. What are you going to do with those?
Plug those numbers into the next one.
Those come here. Only if it makes 0, right? Then those start the next round. Don't start over. That will just cost you a lot of time.
Can you start with 1 again?
No.
I don't
Well,
know.
if you're checking for multiple zeros, then yeah.
Oh.
Yeah, good thing to review.
Or that thing.
Let's say 1 worked and it broke down the function a little bit. If 1 has a multiplicity greater than 1, then it will work again, right? Eventually it would stop working, but sometimes you do have to check for that multiplicity.
Sorry.
That's okay. I get it.
I should only do that.
So back to the project we originally had, since it had
This one?
2 equals 0 and then in the parentheses 2 equals 0, does that mean it's
Okay, but is this a true statement?
No.
Yeah, so I'm glad you remembered to come back to that because this whole thing started by answering the question, how do we use this to graph? This is not a 0. So there is no multiplicity here greater than 1, right? And it's because if you set each factor equal to 0, I mean, that's how we've done it to check for zeros. Well, this doesn't make sense. So it's not a factor. Well, it's a factor, but not a 0.
What if it was imaginary, but it worked then?
No.
Oh.
All right, cool. Do you guys see that really nice, long, skinny slide now? I'll post this, and I would recommend going back through and reviewing that. But we're going to move back to Unit 5 stuff, so let's check your homework. Grab that, please. It's around here somewhere. Where is it? Okay, so 14 is 2x to the 3 halves. 16 is, you can just read. I'm not going to read that one. I guess it's kind of a lot.
Oh, wow. 3y
It's not the answer you're
There you go. Oh, on this one? Yeah, Nate and I checked this at the end of class. This should be simplified further. 1/4 minus 4/4. Right? 4/4 is squared. So we should be doing subtraction on the y exponents. So 1/4 minus 4/4 is -3/4, right? Right?
Yeah.
Okay, where does so this should say y to the 3/4 down here.
Wait, why down there?
Because it's negative. Like if I wrote this up on a line by itself, it would say
Oh, yeah.
y to the 1/4 minus 4/4.
Oh, yeah.
And then that's negative 3/4, so it goes back down to the denominator. There's two of those like that on here. I think this is one of them. Yeah. So a to the 1/3 minus 15/3
This should also be simplified.
is 14/3 in the denominator. Okay.
Oh, I got that one correct.
So it's b to the 14/3 over a to the 14/3 is what you should have. Alright, number 20 is fine. 19/6, 19/4 for y and x.
Nope.
Oh, yep.
Could you go back up to
Yeah.
the A and 14/3? If they were both 14/3, like B to the 14/3 over A to the 14/3, then could you just cancel? It would be over.
No, you can't cancel. You could rewrite b over a parentheses to the 14/3 if you want.
Only if you want.
22 is also fine. So x to the 17/24 over y. And do you want to do that one,
Yes.
Lexi, still? Remember, the way I do it may not be the way you did it, and that doesn't mean you're wrong, assuming you get the same answer, right? There's multiple ways to do these. So, but first, I think a good first step for everybody would be to get rid of these parentheses. So we can take the two inside exponents and multiply. So we'll get x to the negative 1/8, y to the 1/16. And I think at the same time, I'm going to go ahead and deal with cleaning this up a little bit. How?
Like,
Yeah, x's and y exponents, but how are we combining them?
You're
Adding the exponents, right? So we'll get x to the 2/3 plus negative 3/2 times y to the 3/2 plus 1/2.
Can you do that?
Do what?
Because one of the x's is cubed. Oh, no, never mind.
Okay. So 2/3 plus 3/2? Yeah.
On the top, why is it y to the 1/16?
Oh, it should be y to the 1. 4/4, 1. What's a good common denominator for 2/3 and 3/2?
6.
Okay, so what is 2/3 as 6?
4/6.
Okay. 4/6 plus or minus, I guess. What's 3/2 in terms of 6? We're making a common denominator of 6.
Okay.
So 4/6 minus 9/6 is negative 5/6. Okay, over here we just get y. Because it's 4/2, so it's y squared. Very good.
yeah.
Then, you can kind of think of these in two separate pieces if you want. Obviously y minus y squared, or y over y squared, which becomes y to the 1 minus 2. It's just y to the negative 1. Remember that whole sequence? Are you doing okay with your negative exponents? Okay. And then over here, negative 1/8 minus negative, whoops, that's a 5. Minus negative 5/6. These get a little bit you have to be careful with sign, right? Because why is it minus? Yep, because it's a quotient. But it's minus an already negative exponent. So you have a couple options here. Let's do it this way first, and then I'll show you the other one. What's a good common denominator for those two?
24.
Probably the best one is 24ths, right? Anyway, so negative 3 plus 20 is 17. So there's your x to the 17 24ths. Okay, the other thing you could have done is just go ahead and bring this x to the numerator. So it would look like x to the 5/6 times x to the negative 1/8. Or you could flip that one too. I don't know what you want to do, but there's lots of options here. Okay? Did that help? Tom, did that help?
Yeah.
Any others you'd like to do?
20.
He said 20. What? 20?
Yes. I got it almost all right. Minus 5, 17. 7, 9.
Alright, so again, get rid of the parentheses, top and bottom, probably be the faster way. So 3 times 3 halves is 9 halves, and 2 times 3 halves is just 3. Okay, down here we'll get x to the negative 1/4, and what is that? Negative 2 12ths, negative 1/6.
Okay, so we're doing minor difference.
Good?
So,
Alright, what would you do next?
combine.
Okay, so everybody look here. You could take this up and this up since they're negative in the denominator and change the sign if you want. That would keep it addition instead of subtraction.
I feel 8 by coming in.
Alright, so 9 halves minus negative 1/4, and then y to the 3 minus negative 1/6.
Oh, that's fine.
Okay? So bringing them up and changing the sign of the exponent would keep you from subtracting and maybe save you from making a sign error, but you don't have to do it that way. In terms of fourths, how many is 9 halves?
18.
Okay, so 18 fourths, and plus a fourth is 19 fourths. And then here, how many sixths is 3?
2. What? Oh.
Oh, 18.
18 sixths plus another 6.
I was
Okay, so it was just a sign error.
Yeah,
It's fine.
that's easy to do. But.
Yeah.
Okay, you feeling okay with these?
Yeah.
Good. All right, grab your stuff. Let's move on.
Well, I need you to simplify, that's all, and then I add it.
Grab your notes, I mean.
Atkinson, are we on Tuesday?
No?
Oh. Well, we're out on Friday.
Friday we're getting out.
I didn't like it.
That's mean.
Is it Tuesday, Debbie? I just I needed my turn.
Yeah,
I
it's
was just
okay.
thinking because we get out early on Friday. So I was like, I was wondering.
Is it Friday?
Oh, I'm about to chuck this pencil at you right now.
Whoa, hey, that's violent for a Friday.
What?
I'll review it with you, but we're going to move into simplifying radicals. First thing to note is you can always, if I give you something like this, you can always rewrite it as an exponential if you want. So I guess let's review that real quick. Remember we had two versions of converting back and forth between the two, and one was better for mental math. It was the one that we were doing a radical or a root first, and then taking it to the power because that was typically a smaller number to deal with. Okay, but remember the denominator of your rational exponent became your index of your radical. That was the big idea with that. Okay? So you can, if I gave you this exact problem, only n was 4 or something, you could rewrite that in terms of 3 exponentials, if you like that better. But otherwise, you can split your radical up and take the nth root of each piece. Okay? That was the product property. Quotient, just split them up into separate radicals within the division still. So don't lose that division. Also notice this isn't subtraction and addition like we've seen, right? Please make that note before we get in trouble on that.
Do you remember the coconut food book song thing?
Wait, the one that's
Coconut?
like the ABC one?
Yeah.
Where like A came up and then one of them fell down?
Yeah.
Okay, so these are some
What's
easy
the
ones.
relevance in that?
I have.
These are some easy ones, or at least will be pretty quickly, I think.
Whoa, buddy, hold on.
So it's like,
Just let me do one with you, and then you can look.
hey.
Okay. This is an option, again, I just want to point it out. If we rewrote this as an exponential, what would it look like?
Shoot. Oh, 96 and or 96.
R to the 1/3.
No.
R to the
3 X.
3rd. Okay.
No.
And then S will be X.
Okay.
Oh, yeah, duh.
What?
It's because
What is the index of this?
2.
Oh.
It's a 2. And then we have 2 to the 3rd and the 1/2, which makes 3/2, right? Now, I'm pretty sure that you're not going to like that option better. Okay? Most people don't, so I'm just saying you could rewrite it and do stuff with it that way. I just don't think you'll want to. Here's how I want you to do these, though. We're starting, like, it's interesting that Mr. Hale called it jailbreak, because that's what I call it too, and we've never talked about it. But basically, we're trying to get groups out of the radical, groups of how many the index is, okay? So right now our index is 2, so we can pull anything out in groups of 2. Does that make sense? Everything else stays inside. That's the whole idea behind jailbreak, is you can't leave your buddies behind. If you're in a group, you come out as a group, okay? To do that with numbers, you have to prime factor. So, yeah.
Hold on, buddy.
What?
You make me feel like I'm snippy, but I'm not.
Like you're who?
Snippy? Like salty, whatever you guys call it?
He said
Snoopy.
Snoopy, I love Snoopy.
Okay, prime factoring. Just
Yes.
pick a one that you know goes in there. Like 2, right?
2, yeah.
What's the other one? Okay, do 2 again, or maybe do 3 now, or whatever.
Or 8, 6 and 8.
6 and 8 are not primes.
6 and 8 are 4. Oh.
Prime
Sorry.
factors.
But 24 is prime.
I like how we're index accelerated.
I'm working down this side with primes.
3 days.
6 and 4 are not primes.
2 and
Wait,
2 and
what do
12.
you mean, Prime?
2 and
What?
12. And then 2 and 6, and then 2 and 3.
3, 7.
They are. No, 2 is the prime one.
Oh.
Okay, so our primes go down the left, and then usually at the end you'll have that one other one, okay? If you're doing it right and you know what your primes are, this is how it should look, okay? Now, why did we have to do that?
So you get
Because it's Prime.
Because we're going to rewrite this
as 2 to the
as 2, whatever that is, 2 to the 5th times 3 r cubed s cubed. Okay,
Whoa.
how many groups of stuff can we pull out of this?
I'm good.
2.
How many groups of 2s can I take out?
5.
No, there's groups of 2 2s. How many are there in there?
Who's 2? What?
2 2s, dude. Pretty much.
Okay,
No, you can take out an R. To
no,
the,
just
Okay.
this is how many has to be in a group, okay?
Also 2.
2, yes.
So there are 2 groups of 2 2s plus 1 left over.
Oh, I see.
Oh.
Okay, we're going to rewrite for this one, and you won't need this very long, but we're going to write it like this.
Because 2 to the
5 has 4 twos in it, so there's 2 groups of 2 twos.
Why? What's the point? Why? What is the point of
Okay.
this?
You will not want to do this after hopefully 1 or 2 examples, but if you write this all out with groups of 2 specifically shown, do you see that's what it becomes?
Yeah.
Okay. How many groups of 2? How many groups of 2 twos can come out?
2.
2, right? Because if I use my let's write this out even more. If I use my properties of radicals, this becomes that, and that, and that. I don't need the 2, but I'm just doing it for this one.
Right.
I didn't realize this was gonna take the whole way across.
Do you see the sunset on my room right now?
How about
Like 4 different.
looking at this?
I was looking at that.
Okay. If we use the property of radicals, we can rewrite this whole thing that way.
Not good.
Okay. What's the square root of 2 squared?
2.
What's the square root of 2 squared?
2.
Okay. What's the square root of 2?
1.
No.
It's nothing we're going to deal with. We're going to leave that in. Okay? Leave inside.
Its bond is too high.
Oh, jeez.
Hey, don't worry, it's a Friday. It's a Friday.
It feels like one. Okay, what's the square root of r squared?
Oh my god.
Oh, it's 1.
Actually, yeah, R.
What's the square root of r?
Not
Well,
dealing with
leaving.
it.
Not going to deal with it. What's the square root of s squared?
Wait, so it's not my buddy, so we're gonna leave it? I feel like a bad person
Nah,
now.
its bond is just too high. You can bail out. You're
That's
right.
right. Those ones, no one can afford their bond.
Oh,
They're bail. Okay.
that's so mean.
This stuff came outside, so it's 2 times 2, so 4rs. And then staying inside, we have a 2, a 3, an r, and an s. So 6rs. Okay? That is jailbreak. Pull out groups. Like, think of how many groups you can make. Pull any of those groups out. But when they come out, look what happens. Like, yes, this was a group of 2, but when it came out, it's just 2. Right?
My man.
Because it goes through the square root or the 10th root process. Okay?
Did you briefly touch on this a while ago?
Probably.
Yeah.
My man.
Not that it
I
did
don't
any
think
good.
I would have done
It didn't.
that at all.
I read it though.
Good.
I know.
Right. Here's where you will get, I'm hoping by just in a little while, like 20 minutes from now, you'll be able to go from, you'll still need to write out the prime factorization of any numbers, but you'll be able to go from this step to this step without all this middle stuff. You'll be able to do that. Okay? Here's why. Now that you know what we're looking at, can't you look at a 2 to the 5th and know there's 2 groups of 2 that can come out? Plus 1 left over.
That's just 1.
Okay, the 3 has to stay because he's just 1. In r cubed, there's 1 group of 2 and 1 left over, and same with s.
Oh,
And then all the things you're saying groups of, you pull out.
Wait,
Okay.
so Mr.
Can we
Atkins,
try the signal?
Yeah, absolutely.
well, would we have
Do it.
2y on the outside? Because we can pull out 2 groups of y, of 3, a trio. You can pull out a trio of
Actually,
y.
I'm not listening, so I'm just hold on.
Well,
Wow.
Just hold on a second.
I'm on the wrong side of the
No, I'm good.
Sassy fries.
I'm actually not listening to you. Flex, so.
Well,
you're like my dad.
I'm trying to get this set up.
Why are you being so sassy?
Whoa, I wish I
Me?
Wow.
What about her?
had.
So wait, does the prime number
Alright, go ahead.
You just show
So
how
on B, man. Okay, so like.
Wait, why is it B and C? Oh, never.
We just did.
So we can pull out 2 groups of a trio for y.
This is how you do
So with that on the outside becomes 2y.
You can go back to the original one.
Because it's y and y.
Yeah.
What is
Yeah, I
y
have it on
times
right
y?
now. But you
Y
have seen those
squared.
videos with like
Oh, okay. Okay, so See, it'll be x squared.
Yeah.
Since the bells are on, you should give us a quick break.
Sorry, yours like,
Yeah.
oh.
I've had multiple questions now on, do you prime factor with the index? No, it has nothing to do with it. Like if I could just give you a problem like 150 and you prime factor this, right?
Right.
It has nothing to do with the index at all.
Oh,
Okay?
Okay.
So you could start 150 with 2, or you could start 150 with 3 or 5. Like, it doesn't matter where you start. Your prime factoring will be exactly the same. Okay?
Wait, I'm still now confused.
Okay, so
I just started with 2 here because I knew that this was an even number. That's literally the only reason.
I'm struck. Like really stuck.
Okay, she was about to ask a question. And you didn't actually ask me. What was yours?
oh, never mind. Oh, yeah. I think.
Oh, you're getting friendly now that you see that, huh?
Wait, what?
Nothing.
Okay. Wait, no, I didn't.
What's your question?
So when there's like the 5, how we, in the beginning one, we have 3. We don't use that, right? As like a, never mind.
Well, no, I feel like it's important that we answer this. Can you try to ask it?
So like, you see the 3? and
This
the
3?
Are,
This
Yeah.
3 right here?
yeah, and how we put it back up in there with the 2 to the 5th.
Okay.
Yeah.
I think I got it.
We don't put how many times can 2 go to 3.
Well, because 3 is a prime.
Yeah.
So we're done
Okay.
at that point, yeah. So prime factoring 80,
Right.
just to clarify, like 3 is, even though 3 is our index, 3 is not a prime factor of 80.
Okay.
Okay, so the index has nothing to do with the prime factoring. So you could start with 5 if you wanted.
Oops, sorry.
So this becomes 2 to the 4th times 5. Okay. How many has to be in a group to come out?
3.
3 have to be in a group. So I can pull out one group of 2s,
Right.
leave 1 in, right? I can pull out 2 groups of x's,
And
leave 1, and 2 groups of y's,
leave 0.
leave none. Okay? So 2 groups tells us that that's the power of the exponent. So this is going to be 2x squared, y squared, cube root, what am I leaving? 2,
5.
let's just make it 10.
Okay.
Yeah.
10
Thanks.
x inside. Okay?
Yeah, you got that.
So the group count is the exponent on the outside. Okay?
Wait.
Now, you could think of it this way. Ready? Everybody listen and look. We could rewrite this as 2 to the 4 thirds times 5 to the 1 third, that's fine. X to the 7 thirds and y to the 6 thirds. Okay, so what does 6 thirds become?
2.
Okay, y squared. X to the 7 thirds, if you want to write it like this, it's 2 and 1 third. So x squared on the outside, 1 third means it stays in, right? Because if it has a denominator, it's still stuck inside. 5 to the 1 third, that means it's still stuck inside. And then this is 2 to the 1 and 1 third. One group outside, one group inside.
Oh, yeah, yeah.
If
And
that
then the-
helps, you
and then
can
the
think
10
of it.
is the 2 times 5.
Yep.
This part was right.
This 2 left in, this 5 left in, that's the 10.
I love that.
Wait,
Yeah.
so this is done. I
Just
looked
say
up.
like, it was 2 to the 1 and 2/3, then would it be squared inside?
Yeah, good. So here's what he just asked. If it happens to be 1 and 2/3, like if this had been 5/3, one group out, two twos in, so it would say 4, or just 2 times 2.
Totally is. Yeah, I say that. There is the second part.
So there's.
Like I said, Star Bernardin.
Okay.
I'm Star
Let's do that last one.
I'm Star Bernardin.
Okay, fourth. We already did the prime factoring of 80, so we don't have to do that twice.
Too late for you.
How many groups of 2s come out?
One,
One group of 2. 5 stays in. X,
two,
Is that a
2 groups. 9, or
two
Y.
groups.
Y. Okay, and we're leaving a 5 in.
And
The
a
X
Y.
is fine, and a Y. Yeah.
Oh, I got that correct.
So this isn't bad.
Well,
I like it.
do you see it? This is why I said you can go from here to there without having to write all that stuff out. Eventually. Like, hopefully you're kind of getting there.
I'm there.
You're there. Money.
Money?
What? Is this like the limit of how complicated these ones are gonna get?
No.
Aw, why?
What do we?
She asked if this is the limit of how complicated they get.
Wait, so
Yeah,
what's.
maybe. We don't have that much time left.
Yeah,
Yeah,
we
yeah,
have plenty
so
of
like-
We
time.
have 11 days.
Okay, here's a different one.
Whoa, dude. Whoa, my man. Chillax.
For this unit.
So you would just
What
put
did you
all
say,
of that in a
Nate?
cubic root?
I said what we learned so far in
Oh.
this unit. Just as a test.
We would just
No, I think we'll keep plugging along.
No.
Why?
I mean, we need time to study.
Yeah, and I have finals.
I'll give you a
coming
couple days.
up. I have a final today
Couple
actually
days as in 1.5.
for my college class. It's like a take out home final. And I'm gonna fail it because we never
Alright.
put
Over the weekend.
How are you doing with the prime factoring? Do you
Whoa.
feel like you need to practice a little more?
Yes.
Oh my
I mean, if
god.
that's gonna be our homework for today.
No. Do that one
Oh wow.
and that one.
That's mean.
I'll give you.
I don't know,
What's a good starting point to prime factor this one?
Five.
Watch,
5
That's awesome.
million. No, what's that song?
35.
525.
5 and 7.
Okay, so even though it's a kind of bigger number,
It's from the musical Rent.
Oh,
Anyway,
I was thinking of The Office.
Oh,
Sorry.
no.
anyway, even though it's a bigger number, we only have 3 factors, which is nice. Okay, how many groups can we pull out at end of what?
So you can pull out one group of 5, and then
6 groups.
6 groups of 10.
And what stays in?
7 and
Nice.
yes.
Yeah, that was deserved. What's a good starting point for 512?
3,
2.
2.
Either one. You guys, actually 3 doesn't work. Do you know how to check 3? It's really easy and super helpful.
Not at all.
Okay,
Oh, it's like if
Get
you
this
like,
saved
add
in
up to a factor of 3.
if you add these digits up and the number you get is divisible by 3, then 3 goes in. Okay, so this is
That's
5,
7.
6, 8.
That's
So 3 won't work. So let's start with 2.
I just
So
divided
3,
by
so like
5
13 is divisible
at
by
first.
Yeah, 5, 13. Because that would be 5 plus 1 and 6
Oh,
plus 3
no,
is 9.
no, I did
and it doesn't
2.
look like it should be.
Yeah.
I did.
But it is, yeah.
I forgot. I
Two
did
to the
it.
nine. You're good. And it'll be 2 times 2.
I actually like this math. This is fun.
Gabe,
What?
you say that every time we start something.
Okay, now let me point out something.
You said that a lot last week.
You like the easy stages of math.
Yeah. Because I can actually like understand.
Listen. At this point, you know, both in the problem and in this unit, I think you should probably know what 64 looks like.
Yeah. What do you mean?
Instead of going 32, 16, 8, 4, 2, what could we rewrite this as?
2 to the power of
2 to the 6th.
Yeah.
Okay, then we can just go 7th, 8th, 9th, and we don't have to do, 6 more lines of work or whatever.
That's
Okay?
totally what I did.
Me too. I actually knew that out of the back of my
I
head.
just did it.
I was ready.
And maybe you recognize once, maybe if you have your sheet out, you even recognize that 512 is 2 to the 9th.
Wait, is
That,
it
I don't
actually on
expect to have that memorized, but you have it on your paper. Anyway, 2 to the 9th, P to the 5th. Okay, what comes out of this one?
1, 2,
Oh.
and
Five.
2.
Wait, what?
2,
No, it's not.
And
a P,
yeah, P, and then
5th root of,
16.
2.
yeah, 2 to the 4th, which is 16. Okay? Now, one thing I'm going to point out that happens sometimes, you can kind of see it here, but as a grader, it makes it pretty hard. Do you see how that looks like P to the 5th?
Yeah.
Okay. So be careful to tuck that number down in the radical so it doesn't get mixed up.
Mr. Atkinson, what if you just put a lip and then go like that and then just put the 5 on a little pedestal?
Yeah, that's okay. Just make sure it doesn't look like the exponent.
Too late.
Okay. How'd those two go?
Oh, actually, wait, 16. Oh,
2 to the 4th.
oh, I just didn't
You
do
feel like it's gone okay?
Yeah. I think we need a little practice on it though.
Yeah, for all.
Alright, let's complicate it a little.
No, thank you.
No, actually.
Why would you do that?
In terms of things to consider is what I mean.
Alright.
Going back to where we started. And let's start with this one. Okay.
Oh, ow. In terms of calculus.
Hmm?
What?
Okay.
I'm so tired.
Thinking back to, before we do this next part, if I say what's the square root of 4, what do you have to say?
2.
But what else could it be?
Negative
Negative
2. I.
No, there's no I. So when we're solving,
I got that.
so this is another reason why we have to say solve, okay? Solving, we always had to consider both roots. So if you think back, this one would be, the parent function would be a parabola. Let's drop it down actually. Okay, and we have those two different places where the function crosses the x-axis. So we had to, when we solve, we had to consider both. So similarly, not exactly the same concept, but similarly when we're simplifying radicals, that's what we've been doing. We have to account for those potential scenarios like that, okay?
Yeah.
So first thing to note is if we ever have an odd root, do we have to worry about that at all?
No.
No, because remember the graph is this shape, and it's either positive or negative, but it's never going to be both. Are we good on that? Okay. So any odd radical, your answer can just be the way it is. It's fine. But we've had a couple of these where we have even roots, so 4th roots, 2nd root. What was the ones we just did? Square root, 5th root. So like this one, no sweat. We don't have to worry. But on the even roots, if we end up with, like on the outside is what I mean, if we end up with something out there that is odd, we need to put an odd power, we need to put an absolute value on that. Okay, so like this is 5 to the 1st. Does everybody see that?
Mm-hmm.
We took an even root, which was 2, the 2nd root and we ended up with a 5 to the 1st power. So it's the equivalent of doing this and just writing 2. But is that just 2? No, it could be negative 2, right? So we are not solving, we are simplifying. So we need to put absolute value on that so that we force it to be the positive root. Because, again, an even root of ending up with an odd power could be positive or negative. We're going to force it by putting absolute value on it. Now, what if this had ended up being 5 squared? Do we need to put absolute value? Why?
Because it's an even exponent.
So what difference does that make? What is the sign of any even exponent evaluation?
Because it curves up.
Well, it's always, that's, you don't have to think of it that way. If we even exponent something, it's always going to be positive, right?
Right.
Because it's going to be negative times negative. Even number of times will always be positive. Everybody good on that?
Yeah.
So if you end up with even root and end up with an odd power, absolute value. So you force that positive, force it to be positive.
Is that just on the actual numbers?
No, it's also on the letters, but see, this one was even.
Yeah.
So it was okay. So let's go check if we need to add that to anything. That was an odd root, so no worries. How about this one?
It's
2.
odd.
2 to the first, okay? And then how about on A?
Wait. So we only have to do that if the little, the
Four.
index is
Boy,
even?
every single.
You have
Yes.
to do it on
Okay.
all 3 of those. So could you just?
You can just dump the whole thing in.
Okay.
Okay, but you do have to put it on all 3, because all 3 are odd powers after an even root.
Okay.
Okay?
That makes sense.
Yeah.
Super complicated.
Okay.
This is homework.
Do what?
We should use this.
Oh, you're actually asking to do that as homework.
Yeah, they're